So this is my little introduction to trigonometry. Trigonometry is commonly just called trig for short. And of all of the math subjects, trigonometry is my favorite. I love Triggy-Wiggy. I think it's really interesting. And I think the reason why I like it is because well, part of why I like it, there's like a beginning to it and an end to it, whereas other math classes just seem to go continually. And also because trigonometry looks kind of weird at first, but then once you get to understanding the concepts, I find it to be genuinely a lot of fun. So let me tell you, I'm just going to freehand this little video here, and I'll get to the book section in a future video. But so with trigonometry, deals with angle measures. Okay, and we have so sine is written as, so sine is the same thing as sin, and all of your six trig functions, these are the they're operators. Okay, they don't just stand by themselves, and so sine is sin. Then we have cosine, and this is written as cos. We have tangent, and this is written as tan, and we have and then we have the inverses of these. So the inverse of sine, or 1 over sine, is going to be cosecant. And this is CSC. And then the inverse of cosine is going to be secant. And this is SEC. And then the inverse of tangent is cotangent. And this is written as COT. Okay. Now, what is sine? Well, sine is equal to your opposite over your hypotenuse. The cosine is equal to the adjacent over hypotenuse. And the tangent is equal to sine over cosine. But if tangent is your sine over cosine, your tangent is just your opposite over adjacent. And then the inverses, so the inverse of sine is cosecant. This is your hypotenuse over opposite. Inverse of cosine is secant, and this is your hypotenuse over adjacent. And inverse of tangent is cotangent, and this is going to be cosine over sine, which is adjacent over opposite. And one way that you can maybe use to memorize this relationship is by use of SOHCAHTOA. 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 That's sine of opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA. SOHCAHTOA is a great acronym to hopefully help you remember how these work. Okay, something else. Let me show you something. So if we have and I'm just eyeballing this, so if you take your ruler out, it might not be exactly. I'm trying to draw an equilateral triangle. So let's just pretend that this is an equilateral triangle. And let's call this triangle, let's call this triangle A, B, C. Now, if this were an equilateral triangle, then then the sum of the interior angles would need to be actually, any triangle has interior angles summing to 180 degrees. So any triangle, all three angle measures need to add up to 180 degrees. It's another proof for another day. But for it to be an equal angular triangle, each angle has to be the same. So let's make each of these 60 degrees just for the purposes of this argument or this discussion. An argument is just an exchange of ideas. It doesn't have to be a negative connotation. So this is an equiangular triangle. Equiangular triangle means that all angles are the same. And this is also an equilateral. Also an equilateral triangle because all of your sides are the same. And so if we had this situation, let's so how triangles are labeled is that if this is angle A, then this would be side A with a capital, or if this is if 60 degrees, if angle A equals 60 degrees, then BC is just called capital A. Okay, and angle B in this case is also 60 degrees, and so the opposite side would be capital B. If this lowercase c is your angle measure, then the opposite side would be a capital C. Or you could have capital letters talking about your angle measure, and then lowercase letter would be the opposite side. That's just how triangles are read. So this angle goes with this side, this angle goes with the opposite side, this angle goes with the opposite side. Okay. So if angle B is 60, then AC, and this is line segment or line, so then line AC is equal to B, and similarly for the third point. This was simpler in my head. I think this came out confusing, but I think you'll see as time goes on what I'm talking about with this. Okay, so before I do this demonstration here with the equilateral triangle, let's talk about Pythagorean theorem. Now, the Pythagorean theorem is another excellent theorem. I still enjoy the quadratic formula very much so, but this is also very useful in calculus, Pythagorean theorem. And what this says is that a squared plus b squared equals c squared if and only if triangle A, let's go with the angles, side length, so let's go with angle being the capital letters. If triangle ABC is a right triangle. And this is if and only if statement, which is a biconditional, goes both ways. And so this says that a squared plus b squared equals c squared. This implies that your triangle is a right triangle with c being your hypotenuse. And it goes the other way also. If triangle ABC is a right triangle with c being the hypotenuse, then that implies that a squared plus b squared equals c squared. We're going to use this formula to prove something interesting about this equiangular triangle or equilateral triangle. So let's draw the same triangle down here, the 60, 60, 60 triangle. Not much of a triangle there. So if this is a 60, 60, 60 triangle, an equilateral triangle, if we were to cut this down the middle, we can denote that this is a right triangle with the little box in the corner. So this says that this angle is 90 degrees and that this angle is 90 degrees. Now we started with a 60, 60, 60 triangle. That tells us that this angle here is 60 degrees and this angle here is 60 degrees, but we've cut this in half. So this is 30 degrees and this is 30 degrees. Okay. Now, if we start with length, it doesn't matter what the length is. Let's call the length A, 2A. So if our equilateral triangle has length 2A, since it's equilateral, each length needs to have a length of 2A. They all need to be the same. So this whole length is 2A, this whole length is 2A, this whole length is 2A, but we have cut that in half. So each one of these is now only length of 1A. The question becomes, what is your height? And so if we just look at one half of this triangle, a 30, 60, 90 triangle is a very common triangle you should be familiar with. And what is the height? Okay, so apply the Pythagorean theorem. We have a squared plus our b squared, in this case is the height, is equal to c squared. Okay, solve for h. So we have a squared plus h squared equals 4a squared. You square the right side. Subtract a squared from both sides. This implies that h squared is equal to 3a squared. Take the square root of both sides. That tells us that h is equal to plus or minus a radical 3. Or radical 3 times a. I just chose to put the a out in front just to emphasize that it's the 3 being square rooted and not the a being square rooted. Okay. But since your height is a length, you cannot have negative length. Therefore, we're just going to take the principal square root. And we have that the height is equal to a times the square root of 3. Now, to make things simpler, we will use the unit circle in a lot of our trigonometric functions. And the unit circle has a radius of 1 unit, or 1. So if we set your length equal to 1, what you get is if we set the hypotenuse equal to 1, so this all equal to 1, then the base is 1/2 of that. And the height is the base times radical 3, or your height is the base times radical 3. You have root 3 over 2. And this happens on your 30, 60, 90 triangle. So this would be 60 degrees, this would be 30 degrees, and then we have our 90-degree angle over here at the edge. You should be familiar with your calculator. This in your calculator is about 0.8660. You'll see this number lots of times when you use your calculator. And 1/2 is 0.5. A similar discussion can be had for the 45, 45, 45, 45, 45, 90 triangle. So again, this is supposed to be a 45, 45, 90 triangle, even though if it's not really drawn to scale, there's your box that denotes you have a right triangle. And if this is 45 and if this is 45, what you have is an isosceles triangle. So a triangle that has two angles being equal will also have two sides being equal. And very similar as before, if we call this length of 2a and this a and this a, using the Pythagorean theorem, we have a squared, no. If we're using the unit circle and this has length 1 unit, then what is x and what is x? If we're on the unit circle, the hypotenuse being 1. What this is x squared plus x squared equals 1. We have 2x squared equals 1. This tells us that x squared is equal to 1/2. So that x is equal to, and again, we just want the principal square root because we don't want negative lengths. The square root of 1/2 is going to be radical 2 over 2. And this is a relationship that you need to be familiar with to be successful with trigonometry. You need to understand the basics of a 30, 60, 90 triangle. Any 30, 60, 90 triangle is going to have, well, the relationship in a 30, 60, 90 triangle with your hypotenuse being 1 is going to be radical 3 over 2 is your long side, 1/2 is your short side. For your 45, 45, 90 triangle with a hypotenuse of 1, you're going to have root 2 over 2 as your length. And since these are the same length, this is also going to be root 2 over 2. Okay. All right, that's my intro to trig. I will solve some problems in the next video. Thank you very much. Please go to tutoring.